Okay, well we're given a study of 50 random people. Found that the center is around 66, so this is our center right here. And we went and did a simulation of 100 trials. So there are 100 dots here. And what we want to do is we want to try and draw lines that separate the middle 95% of the data. Okay, well, the middle 95% means I only want to eliminate about 5 pieces of data if that's possible. If not, I'm going to get darn close. So if I'm going to measure from 66 and I want to kind of do, it's a trial and error thing here. If I want to include all the way down to here, that means I'm subtracting 0.6 and I'm adding 0.6, that gets me up to 72. So if I'm only doing that, I'm including everything up to 72 and everything down to 0.6. Well, if I count up the dots that are outside there, I've got 3 here and 4 here, so that's a total of 7. Can I get any closer? Well, if I took one step further and went all the way out here to 0.73, I would go one step further here and it wouldn't really include any more. So I'm really only eliminating these guys on the outside. So I'm eliminating 4 instead of eliminating 7. 4 is a little closer than 5. These guys are all off on one side anyway, so it's going to be pretty symmetrical with what the stuff we have left. So the interval I'm creating is going to go all the way up to include 73 from 66. So how much am I adding? Well, I'm adding up 7. That's my margin of error. So 0.07 is my margin of error. If I add that to 0.66, then my upper bound is going to be 0.73. Okay, and my lower bound, if I subtract that, is going to be 0.59. And so there's my interval, there's my margin of error. If we did a follow-up survey that found that 57% of people eat fast food at least once a week, would this be considered statistically significant? The answer is yes, because this is below my interval. Statistically significantly different than what we found. Well, 95% of the data is above 59, so 57 being below that would be surprising. Yes, it would be. Yes, it's outside my 95% interval. Oops. There you go.